Okay, so we're going to go on into our right triangles. We're going to talk about the Pythagorean theorem to start off with, which I know it's a concept we've already talked about, so we're just going to review it over really quickly. So, Pythagorean theorem, it's only good on, as it says, right triangles. What this theorem is, kind of as a review, it's the leg squared plus the leg squared equals the hypotenuse squared. So if I look over at my graph as my example, what sides are my two legs? Where they're the ones that form the right angle. So in this case, it's going to be a squared plus b squared equals c squared. One other way we can look at this as well is if I'm given the hypotenuse, so I got c squared, but then I'm minus a leg, so minus b squared, that's going to equal my other leg squared. So that's going to equal, so c squared minus b squared equals a squared. Okay, so next we have the converse of the Pythagorean theorem. What the converse is if we're told the last part. If a squared plus b squared equals c squared, then we have a right triangle. So that is our converse. So I'm given three sides, and we got to find out if the three sides satisfies the Pythagorean theorem, then it is going to be a right triangle. So let's look at some examples. So if I have my two legs, I have 12 squared plus 15 squared. So, to find AB, that's the hypotenuse. So I have 12 squared plus 15 squared. That's going to equal c squared. Okay. Well, I know 12 squared. I know that is 144. I know 15 squared is 225. And that's going to equal c squared. Add these together. 5 plus 4, 9. 2 plus 4 is 6. So I get 369. So when we add the 12 squared plus 15 squared, like I said, we get the 369. So that equals my c squared. Well, how do we get c by itself? We take the square root. Well, if I try taking the square root of 369, I get a decimal. And since we don't want decimal answers anymore, we have to simplify. So I got to take my 369, break it down. Well, I know I can factor out a 3, which gives me then 123. Well, I'll take that 123, divide by 3, I get 3 and 41. Can't break 41 down any further, but I got two 3's, so that means my AB equals 3 square roots of 41. So that would be my answer for AB. All right, if we look at part B, I want to find EF. Well, is EF a leg or my hypotenuse? It is my leg. So I'm going to follow this equation. I'm going to take my c squared. I'm going to minus my leg squared. So I'm going to take 10 squared minus 7 squared. That's going to give me my a squared. Well, see, 10 squared is 100. 7 squared is 49. I got 100 minus 49. That gives me 51. So that's going to be my a squared. Well, if I try taking the square root of 51, once again, I get a decimal. So I got to break it down. Well, 51, I can divide by 3, which gives me 17. Can I break 17 down? I can't. So we leave our answer as the square root of 51. So there's my answer for EF. Okay? The next example. If a triangle has sides of 35, 37, and 12 centimeters, is this a right triangle? So we got to find, since we're trying to figure out if we have a right triangle, we're going to follow our converse. So I got to see if a squared plus b squared equals c squared. Well, what do we know about our hypotenuse? Our hypotenuse is always the longest side. So which one's my longest number here? It's 37. So that means I got to take 12 squared plus 35 squared. I want to know, does that equal 37 squared? So let's find out. If I take 12, so 12 squared, we know that's 144. If I take 35 squared, that's 1,225. I want to know, does that equal 37 squared? So that's going to be 1369. Well, if I take the 144 plus 1225, I get 1369. Does that equal 1369? It does work. So is this going to be a right triangle? Yes, it is. And this is how we explain. All right, so that is using Pythagorean's theorem. We're now going to get into what's called special right triangles, which they are going to be applied, or when we have these special rights, there are two types of special right triangles. There are 45, 45, 90 degree triangles and 30, 60, 90 degree triangles. There are some difference between the two. If I have a 45, 45, 90 triangle, that means I have an isosceles triangle where my two angles are congruent, which means my two sides are congruent. Well, since this is a right triangle, I could use Pythagorean's theorem to find out what BC is. Well, if I do that, or I can follow this equation. So, BC, or the hypotenuse, in a 45, 45, 90, it is the side times the square root of 2. And then, of course, the two legs, so AC and AB, which are the legs, that's going to equal just that value of S. So that is our 45, 45, 90. The other triangle is a 30, 60, 90, which a 30, 60, 90 triangle is formed by an equilateral triangle, where this side is a bisector to the side of my equilateral and my angle, which causes BC to be S. So that we're going to call that our short side. So our short side is S. Okay, we also have the hypotenuse. We also have a long side. Well, to find the hypotenuse, since this is from an equilateral triangle, if this section is S and it cut this whole side in half, that means AB, or my hypotenuse, is 2 times S. Then I can use Pythagorean's theorem with 2S and S to find my other leg, or I know it's going to be S square roots of 3. So these are the rules we're going to follow if we are dealing with a 30, 60, 90 triangle. Let's look at some examples using our special rights. So first off, I want to find XY and YZ. Well, if I look at my triangle, what type of triangle does it look like we have? Well, we have a 45, 45, 90. What side am I already given? I am given I'm given one of the legs. So since I'm given one leg, that means my other leg is the exact same. So XZ is also 7. Well, then if I follow the rule from before, the hypotenuse is the leg times the square root of 2. So YZ is 7 square roots of 2. There's my answers. I got XZ, which is 7, YZ, which is 7 square roots of 2. Okay, let's look at our next one. I want to find JK and LK. Well, if we notice, the side we're given is my hypotenuse. Well, if we recall from the equation, isn't the hypotenuse S square roots of 2? Since this is already a root of 2, my number out front, that's going to be my side lengths. So that means JK is 12 and LK is also 12. So both of these values are 12. All right, next we want to find PQ and PR. Well, what type of triangle are we given? Well, I have a 30, 60, 90. And what leg am I given? Am I given the hypotenuse, the long leg, or the short leg? I'm given the short leg. If you recall from the rules, the hypotenuse is 2s, and the long leg is s square roots of 3. And then, of course, the short side is my s. So what's going to be PR? PR is going to be the hypotenuse, so I got to plug 6 into s. Well, 2 times 6 is 12. So PR is 12. Same thing, plug my 6 into s for PQ. That means I'm going to have 6 square roots of 3. So there's my two sides, 12 and 6 square roots of 3. Okay, next example. Once again, I have a 30, 60, 90 triangle, but this time I'm given my long leg. Well, we know the long leg is s square roots of 3. We know the short leg is s, and the hypotenuse is 2s. Well, doesn't this equate this part, the s squared to 3, match up with our s squared to 2 from our 45, 45, 90? And since I have a radical 2 here, the number out front was my length. Same thing applies here. I have a square root of 3, which means my number out front is my s. So what's s? S is 9, which means what's going to be my hypotenuse? 9 times 2, which is 18. So UV is 9, TV is 18. All right, let's look at our last couple of examples. So we have our 30, 60, 90 triangle, and I'm trying to find AB and BC. So once again, I'm given the long leg, which we know is s square roots of 3. I know my short leg is s, and I know my my hypotenuse is 2s. Well, this is different because it does not match up with a radical 3 already in the question. So what we got to do is we got to solve for s. So I'm going to take the side I know, so 28 equals s square roots of 3. Well, if I'm going to divide, or if I want to get s by itself, I have to divide by the square root of 3. So those cancel out. I got s equals 28 over the square root of 3. Well, I cannot have a radical on the bottom of a fraction. So this I have to rationalize, which means I got to times by 1. In this case, my 1 is square root of 3 over square root of 3. When I times the two radicals together, the radicals cancel out, so I'm left with 3 on the bottom. Then I'm going to times the top together, which ends up being 28 square roots of 3. There is my s. So my s is 28 square roots of 3 over 3. Well, if I want to find my AB, I now have to times this by 2. So in other words, I times the top by 2. 28 times 2, well, that's going to be 56 square roots of 3 over 3. So there is my hypotenuse. There is my short leg. Okay, we're going to follow the same concept, but now I have a 45, 45, 90 degree triangle. So we know we have s square roots of 2, and then s and s. So just like we did on example H, I got to take 14 and set that equal to s square roots of 2. Just like we did here, I'm going to divide by the square root of 2. So those cancel out. I have s equals 14 square roots of 2. Same thing, just like this problem, I can't have a radical on the bottom. So instead of timesing by square root of 3 over square root of 3, I'm going to times by the square root of 2 over the square root of 2. Once again, the bottom's radicals cancel out, so I'm left with 2. Out front, I got 14 and square roots of 2. Just like we could do with fractions, look at the numbers outside. Can I simplify? Can I simplify 14 and 2? I can. I can factor out that 2. So I'm left with 7 square roots of 2. which means my two side lengths are 7 square roots of 2, 7 square roots of 2. So there are the lengths of those triangles. Okay, so this is Pythagorean's theorem involving special right triangles.